Hello friends, in this video we will see how to insert a node at a specified position inside a linked list. So first let's say we are asked to insert a node at fourth position in this linked list. So first we'll create a new node by demanding memory, right? And we'll insert data in that node. Let's say data is 10 inside that node. And now that node will be inserted at fourth position. So that means we'll insert this node in between 3 and 4 so that after insertion this node will be a fourth node. So now I'll simply take a pointer at a position which is position of insertion -1, that is 4 minus 1, 3. So I'll take a pointer here, Q, right? So now what I'll do is I'll simply make P arrow next, that is next pointer of P will point to the next pointer of Q, right? Next pointer of Q is pointing to this node, so next pointer of P will point to this node. So now this pointer was null, I'll make it point to this node. I'll create this link and then I'll create this link by saying Q arrow next is equal to P, right? So I'll get this node inserted. Now this is the node which is inside this linked list or in this linked list. Okay, so now if you count the number of position, it will be on fourth position. This will be fourth, then this will be fifth node, and this will be sixth node, right? The problem is how to get to that position Q, how to take a pointer to that position 3, right? So we'll start at head. Let me redraw the linked list. So we only know the address of the first node of the linked list. How to take a pointer to position of insertion -1, that is to this position. So I will simply start at head because I know the address of only this node which is stored in head. So I'll start my Q here by saying Q equal to head. Then I'll simply increment my pointer Q to Q next till I reach to 3 or till I reach to position -1, that is position of insertion -1. So while I'll simply say while my counter is less than position -1, Q equal to Q next, right? So let's write a code to do this insertion, C code to do this insertion, right? So let's say here is our function insert. The return type of insert function will be struct node, assuming structure node is the node used to create a structure or to create this node, right? So insert, to this insert function we need to pass the address of the first node of the linked list. So we need to have a pointer, right? Struct node star, let's say head. Then we also need to tell insert what value to be inserted in the node, int x, and we also need to tell insert the location of insertion, right? So int L, right? So now inside insert I'll need, as we have seen, we'll need one more pointer Q. So I'll declare it one pointer of Q which will traverse the linked list and the other pointer P which will help us to create a new node, right? So we'll declare those two pointers, struct node star P comma star Q, right? So we'll need some integer variables, int I and few more if required. Then first thing I'll do is I'll create a node. So P is equal to struct node star malloc size of struct node. So this statement will create demand memory, and the memory will be pointed by pointer P, after type casting that memory or address written by malloc into structure node type address. So then we'll assign x to p arrow data. So the data part of the memory pointed by p will get x, and then we'll set next pointer to null. Now we'll start our queue at head node. Right? That is, we'll start our queue here at head node. Okay. So I'll say queue equal to head, because I have the address of the first node stored inside a pointer head, because I have received that address of the first node, the linked list, inside a pointer head. Now I already have initialized my pointer to head node. I'll have to start going from 2 to n to position of insertion -1. So I will use a loop for I assigns to 2, because I want to go from 2 to position of insertion -1. That is, I assigns to 2, I less than equal to L minus 1, I plus plus, right? So, and then I'll simply say q equal to q arrow next. Simply increment the pointer till you reach to position of insertion -1. Simply take q to q next. Q next is the next node address. Right? So once I reach there, let's check whether this loop works in this case or not. Right? So here is our q. Our L is equal to 4. Right? So our I is 2. So 2 is less than 4. So execute for loop. For loop says q equal to q next. So q will be q next, because q next is pointing here. So q will also point here. Right? Now we go up and increment I becomes 3. Right? So 3 is less than so L minus 1 is 3. So 3 is equal to 3. So condition is 2 this time also. That means execute the body of for loop, q equal to q next. So q will be here, right? So we wanted to bring q till this point. Our loop should not allow the q to go further. So now I increment I becomes 4 this time. So now condition is false, right? Because 4 is not less than or equal to 3, right? So our q is now on the desired position, right? So now once I am there, what I'll do is I'll simply say I already have p created here. Already have p here, right? I'll simply say p arrow next. First I'll create this link, right? I'll simply say p arrow next equal to data q arrow next, because this node is being pointed by q arrow next, this pointer. So I'll simply say p arrow next equal to q arrow next, right? And then I'll break this link and I'll create this link, right? So this link means this is a q arrow next pointer, right? So q arrow next will point where p is pointing to this node. So q arrow next equal to p, right? Thus the node is inserted, and now I'll return the address of the modified linked list to a calling function. So return head. Okay, so this code is for insertion of a node inside a linked list, assuming the position of insertion is not 1, right? Or the position of insertion is not which is out of a linked list. That means, for example, if you have 5 nodes inside linked list and somebody is asking you to insert at 10th position, so this code does not take care of that, right? So if you the code for insertion of a node at the beginning I have already discussed in one of my previous videos. So it's a very easy code. You can modify this code also to take care of position of insertion. If position of insertion is 1, right, you can simply check here, right? If L equal to 1, that means you want to insert a code, a node at the beginning. So let me write the code here for insertion at the beginning, right? So you can just add this code here, so you will get a complete code which takes care of insertion at beginning. This code also takes care of insertion at the end, right? And insertion in between. Okay, so if L equal to 1, that means position of insertion is equal to 1. So what we do is, if we have this linked list here, right, and we make new node, then this is being pointed by P, and this is Q, sorry, head node, and our new node is P. So in this case we simply say P arrow next equal to head, right? So if position of insertion equal to 1, we simply say P arrow next equal to head, P arrow next equal to head. And then, as this is the first node of the linked list, our head changes, we should bring our head node or head pointer to the first node, so head equal to P, and then return head. So that's a very simple code. If the position of insertion is 1, if you just plug in this code here, this will be a complete code for insertion of a node inside a linked list, whether the position is first position, last position, or any other position. Okay, so thank you for watching. So stay tuned to watch other videos on linked lists and any other topics in C programming, data structure, algorithms, and many more things. Thank you.